obviously we're talking about ReactiveCocoa today. I've entitled this presentation, Learn You a ReactiveCocoa for Great Good. That's kind of an allusion to any of you have seen. There's a book on Haskell called Learn You a Haskell for Great Good. And the reason that I entitled it this is because a lot of the presentations that I've seen on ReactiveCocoa have really kind of only made it look like a glorified key value observation. And really it's a lot more than that, and if you will let it, it becomes a whole new programming paradigm that you can adopt. So, there we go. This is a picture of me. That's me touching MC Hammer, actually. I'm Jason Larson. I'm a software engineer at Instructure. And I've been there for almost 2 years now. I'm doing iOS development there. So, who here has experience with a functional programming language? A couple. What languages?
Elixir and Erlang.
Elixir and Erlang. Okay.
I don't have experience with functional programming.
Perfect. Okay. Perfect. So, because the first thing we're going to talk about is functional programming. So for those of you who don't have experience with functional programming, I would highly suggest that sometime, at some point in your career, hopefully sooner rather than later, you take the opportunity to experiment with some functional programming languages, because it will really change the way that you think about programming, and whether or not you decide, to like use them in production or in your fun side projects or whatever is kind of irrelevant. It's more of introducing a lot of new ideas and concepts that will help you become a better programmer in general. Some of the key tenets of functional programming are following. No state. So functional programming is all about not having state, which, I should say pure functional programming is about not having state. And as we all know in practicing computer programs, it's kind of hard not to have state. So we're going to talk a lot about state in this presentation. And not so much we're not going to talk about how to be like have a pure functional approach, because that's not possible for us. But we're going to talk about how to eliminate as much state as possible. And in fact, most common programming or functional programming languages right now are not purely functional. They do have state, but they control the state in a way that helps with like multi-threaded situations and whatnot. But state is where most of the bugs in programming come in from, right? Like there's a reason that you have to power cycle your computer. It's because something in your computer is in a certain state that it's just got a bug, but if you turn it off, then you reset the state and you're not going to have that bug anymore. So state is one of the things that produces a lot of bugs. Also in functional programming, we don't have any side effects. And so side effects are things like, say you call a function. In functional programming, all it does is it will return the same output every time for the same given input. And it won't go and like change some global variable somewhere. It won't do anything that you wouldn't expect it to. All it can do is return a value for a given input. Immutability. So this just means that the data sets that are inside of a pure functional programming language can't change. So I can't take an array that's 1, 2, 3 and change it to be 3, 2, 1. What I have to do is I have to create a new data structure that transforms that. And then first-class functions, which are functions that we can treat as objects. So if you look at these things, you'll see that we have a lot of this in Objective-C. We have first-class functions. We've got blocks. We've got a lot of immutable data structures. And side effects, well, that's something that we can choose to enforce on ourselves. We can put side effects or not put side effects in our code. And then no state, obviously we can't not have state, and we can't not have any side effects either in our apps, but we can choose to try and eliminate these as much as possible. So that's a little bit on functional programming. If you're looking for like a functional programming language that you want to try out, I know Robbie and I really like Elixir. Although recently I've been getting really into Clojure. Clojure is a really cool Lisp derivative. And yeah, so those are two that I think are really popular right now that have a lot of good community around them. So now we're going to talk about reactive programming. And what is reactive programming? I think that the best way to think about reactive programming is to think about a spreadsheet. So in a spreadsheet, when you make a formula, that cell with the formula in it is dependent on the value of other cells. And as soon as the values in the other cells change, that cell will immediately react, and its value will reflect the updated values of the other two cells. So for example, if this is just a simple spreadsheet, in the bottom column, these two, in the bottom left, are just the sums of the rows above them, and on the far right, then that's just the sum of the other two columns. If we were to change the 2 to a 5, those values would automatically be updated. And so that's kind of the idea about reactive programming. And we want to start thinking about what can we do in our programs to make the outputs of things be dependent on the state of other values.
So Jason, real quick, so is functional programming and reactive programming, like, are those synonyms or just still separate things?
They're separate things.
Okay.
Yes. But when you put them together, you get functional reactive programming, which is what ReactiveCocoa is trying to do. It's trying to create an environment in which you can do functional reactive programming. And it's not going to be purely functional because we're in Objective-C. We've got state. We've got all these things we have to deal with. But it's going to try and help us be able to reduce the amount of state in our application and to reduce the amount of side effects that we don't know about, and therefore to have less bugs, and also to be able to think about our data in a more elegant way. So, one property of functional reactive programming is that it's declarative. So, this code right here says that basically we're going to bind the value of the name property on self to the text value on that label. And so whenever we change name, no matter where it happens in our code, that our text is automatically going to get updated to reflect that. And this is a little bit, like, this is a very simple example, but this is declarative because we're not writing any code to actually set the name. These are actually just like really super fancy, crazy macros that the guys at GitHub wrote. I should say the guys at GitHub are behind ReactiveCocoa. They're all really smart, and they put a lot of time into this, and it's a really great framework. But, so this is declarative because we're not writing any of the KVO stuff. We're not telling it to observe anything explicitly. We're not, you could also do this maybe like hey, I can do this by overriding the setter for name. And I can just tell every time I update name that I'm going to set the text label. Yeah, you could do that, but that's much more explicit than this. So functional reactive programming is declarative. Reducing state, we already talked about this a little bit. We're not going to try and eliminate state, we can't do that, but we're going to try and get rid of as much as possible. So the key object to understand in ReactiveCocoa is the rack stream. It's kind of like the basis of everything. And the way that I like to think about it, think about like a stream as like a pipe. And there are values of data just flowing through it. And you can subscribe or listen to this pipe, and as the values come through, you can do things with those values. And there are two main subclasses that you'll use in ReactiveCocoa. There are subclasses of rack stream. And the first is rack sequence, which is pull driven. And we'll discuss what that means in a minute. But rack sequence basically is what you will use if you want to kind of take a more functional approach to your data structures. So if you want to take your existing Cocoa data structures like your NS arrays and to use them with the kind of the functional methods. And then we have rack signal, which is much more common, and that is push driven. And you can think of that kind of as like an event emitter. And when you subscribe to it, you're kind of getting the values as events to push them to you. So, rack sequence. This is an example of how you might make a rack sequence. So, you have an array, 1, 2, 3 of these NS numbers, and you can say .rack sequence on it. What this does is it creates its own collection that can be used, and then you can start calling all these ReactiveCocoa methods that you can call on streams on your collections. So this in and of itself isn't very useful, right? So how can we transform our streams? The next couple methods I'm going to show you are not exclusive to not exclusive to sequences, but we're going to demonstrate them on sequences, because you don't really ever create a rack stream. You either have like a rack signal or you have a rack sequence. So I know not many people here have used a functional programming language, but are any of you familiar with the methods like map, filter, reduce? Maybe you've seen them in Ruby or similar type languages. So, can I get a, who's seen that?
Filter in Ruby.
Filter, okay. So, a little bit of familiarity. The first thing we're going to talk about is map. So this is a function that will take, so what it does is it creates a rack sequence, and then we go over that sequence, and we're mapping that sequence, so each value inside of that sequence is going to get mapped to a new value, and the mapping function that it's going to use is the block. And the block, what it's doing is it's taking the NS numbers, getting the integer value for them, and it's multiplying them together, so essentially we're squaring them. And so what this does is basically it will go through the entire sequence of numbers and give us a new sequence, and in that new sequence we only have the squared values of all the numbers in the previous sequence. Does that make sense? Maybe this picture will help with that. So we have the array 1, 2, 3, and then we have some mapping function, and when we pass the array into our mapping function, well, it's actually more accurate to think about the mapping function as being applied to each individual element inside of the sequence. But then we get some resulting sequence out of it. And so you might say, Jason, I can do this with for loops, and I think it looks better. And maybe it does, I don't know, it's a matter of opinion. But so here's the for loop that does the same, right? And yeah, so some of the things that I personally don't like about this is I hate having to create a mutable array every time I want to manipulate something. And so the other one kind of abstracts it away from us. I mean, underneath the hood it's obviously probably doing something with mutable data structures, but you don't really care what it is. And so this really just kind of gives us an opportunity for abstraction. Like loops are something that we do a lot, especially if you're doing like, so this is a for each loop, but if you're doing like a normal for loop where you had like to increment your value, then that is it's not very abstract. It says that you know a lot about the data structure and how the data structure works and how you can traverse the data structure. And the map is a much more abstract view of how you can traverse your data structure. Another really cool thing about sequences that you don't get with loops is lazy evaluation. And what this means is that your rack sequences will only do as much work as they need to do. So if you say, we're going back to the squared example, say we have an array of the numbers 1 through 100, and we run that through the map, but for some reason or another we only end up using the first 5 values. If we had run the for loop, it would have gone through and done all the calculations. If we're using a rack sequence, it only calculates the values as we pull them out. And it's why it's called a pull-driven string. So every time I access that value, it does the computation and gives me the result. And so the nice thing about this is that I'm not wasting computation. Now there might be situations in which you want to do all the computation up front. In that case, you've got this method called eager sequence, which we'll just go through and do all the computations. And so, yeah.
So, do you know how it keeps track of, so if you did the thing where you squared all the numbers, how do you make sure it's not doing that like multiple times on that data structure or the sequence?
So the map function will only traverse it once, and it will return a sequence. And that sequence has basically it's not yet computed, but it will compute it on the fly. So I'm not sure exactly what you mean, but it won't run through the sequence more than once, and it won't do the computations more than once.
Okay, so if we have that array of like numbers 1, 2, 3, if it ever needs them, it does the squaring of them, but then it's just that's the new values, and they don't need to be done anymore.
Exactly. Cool. Any questions so far? So filter.
Wait, were you going to describe what the tail and head were now?
Okay. Yeah, so tail and head. So head just means you're accessing the head of the sequence. You can think of it kind of abstractly as like a linked list. Is everyone familiar with that data structure? So the head would be the first element in the linked list. And so if you access the head in this case, I forgot to put this example. So like what this example is doing is that it's just going through and is appending an underscore to all of the strings in the array. And so as I access the head, then it goes through and it evaluates and it returns the value. And so the tail of that would actually be everything starting with B all the way to the end. So the head's the first value, tail is kind of the rest. And so by doing tail.head, I'm saying the rest of it, but the first item of the rest of it. And you really don't ever do this. It's just demonstrating the laziness of it. Okay. All right. Filter. So filter does kind of exactly what it sounds like. It filters out values that you don't want from your data structures. So an example of that is maybe we have an array of numbers and we only want even numbers. So similar to map, what we do is we supply a function, which is our block. And our block tells us, it gives us something that returns true or false. And if it returns true, this item gets included in our new sequence. If it returns false, then it doesn't get included in the new sequence. So this will mod it by 2 and see if the remainder is 0. If it is, then we know it's even. And so we'll return true. And so this way, only things that evaluate true are going to be in our new sequence. And a little bit more graphical representation of that is this. So we just have a filtering function which gets applied to each element. Only the elements which pass get included in the new one. Now we're going to look at something a little bit more advanced. Yeah.
Really quick, does that also happen dynamically, or is that immediately?
Yeah.
Okay.
So I don't know exactly how it works implementation-wise, but it will be lazy as well. Yeah. I mean, it probably just will go through until it finds the next value that is the true. Do you have a question? Okay. Oh, whoops, we're skipping ahead. Okay, fold. This is also known as reduce. Fold is a little bit more mathematical term. And also in Ruby, sometimes it's called inject. Have any of you had experience with this method before? Who haven't done functional programming? And the rubber hats. Okay. So this one's a little bit more, you don't have to understand this one. I'm just more exposing you to it. But hopefully I can explain it in a way that you can grasp it. But basically, unlike the other ones which don't know anything about, so like map and filter don't know anything about the items that came before them. They don't have any sort of history, or you don't have any way of kind of keeping some sort of state as you go through these. And so what fold does is as it iterates through, it gives you an accumulator. And you pass that accumulator value with you, and you get to keep that value in each iteration. So we have a sequence of numbers, and fold left with start. We'll discuss what the left part means maybe a little bit more in a second, but it means it starts on the left. And our block, you'll notice this time takes 2 parameters, the first of which is the accumulator, the second of which is the actual value that's coming out of the sequence. And then we also have with start, and we have an NS number of 0. So what this function does is it starts with 0, and it's going to go through and add that value, and then it returns the sum. And so what you're returning becomes the accumulator for the next round. So you have a folding function. You have some sort of, we have 2 inputs basically this time. This is the start. Oh gosh, my flux is kicking in. Let's see if we can turn flux off. Maybe not. Oh, we'll do it. Whatever. You guys don't save your eyes. Thanks to and then you have your sequence that you put in. And then you get out whatever the accumulator was at the end, which in this case is 6. And if we want to look through all the steps, each of these lines is one of the passes. So the first one is just its initial state. The first one through the red is what the current value is. And so we add the accumulator with the current value, and we have 1. And the next pass, and green just means we've already looked at that. So the next pass, the current value is 2. Add that to the accumulator, we get 3. So on and so forth until we get 10. Does that make sense? And so this can be used for a lot more than just sums. Another example of what you might use this for is if you have maybe like an array of words and you want to create some sort of histogram so that you can map a word to the frequency in which it occurs. This is an example where you could use that. There are a lot of examples of things that you might want to use this for. But that said, you'll probably end up using map and filter a lot more. Any questions? Okay. So combining streams. The first method we have for combining streams is concatenating them together. And so in this example, we have an array of numbers, an array of letters, and then when we concatenate them together, it just appends the letters to the end of the numbers. So if we had 1, 2, 3, and ABC, then we'll have one array, which is 1, 2, 3, ABC. Flattening sequences. So this is for when you have sequences of sequences. So, for example, if you have a sequence, and the first item in your sequence is a sequence of numbers, and the second item in your sequence is a sequence of letters, then if you flatten them, then the resulting value is just them concatenated together. Does that make sense?
How is that different than the previous slide?
It isn't, except this is, so, I mean, what you could do in the previous slide is iterate through everything in the sequence and concatenate them together, and that's what flattening basically does.
I guess if you had 3, then you'd have to do concat these two together,
Right.
then concat the third one with the
Yeah, so
results
this-
of the first one. So this does all 3 of them in
Okay.
one.
Okay. Oh, my slides might be out of order. Okay, we're going to talk about flattening signals, even though we haven't talked about signals yet. Just so you know, flattening signals merges them. So flattening a signal, even though they're both streams, flattening a sequence and flattening a signal have different, they're different because they're different types of streams. But we'll discuss that more later. Right. And got another signal thing in here. We'll come back to this. Okay, so rack signals. Signals, unlike sequences which are pull-driven, meaning you ask for the values and it gives you the values as you pull them out, rack signal will push them to you as events happen. So here is an example where you have some text labeled, and the signal in this case is this rack observe self total. So we have some property on self called total, and we're making a signal. And what rack observe does is it makes a signal by key value observing whatever is inside of the parentheses. And so in this case, we're observing total, and every time total changes, our signal emits an event, and we can subscribe to those events and see what happens. But an event is this signal is a stream, so we can transform the values as they come through. So in this case, maybe total is an NS integer, and we want to map the value of whatever total is into a text label.
Yeah.
And so you can't just shove a number in there. We have to do some sort of string formatting. And so what this does, just like map with well, not just like the sequences, where sequences we can take our sequences and have them as data structures. But similar in that every value that gets pushed through here, we apply some sort of mapping function to that value, and we get some sort of new result out. So say that gets changed to 6, then it comes through our mapping function, and the result that comes out of that is the string 6 units. If it gets changed to 7, then it's going to say 7 units.
And this is push in the sense that once self.total changes, it's gonna come right through, right? We don't have to ask for
Exactly.
it.
We're not saying, hey, give me the next value of the thing. It's, oh, I got an update to this value. I'm going to map it and put it inside of the text signal.
Okay.
Okay. Filters. So we can also filter signals. Maybe in the previous example, you know, we only, for some reason, want to handle even numbers and put them in the thing. And so we can map to the value and just see if it's even. And then in this case, if it's not even, then the event doesn't go all the way through into the, it doesn't get pushed into, well, okay. So in this case, we're not actually using the text label anymore. But, so total will only ever be even values of cell 1. That makes sense?
Yeah.
I didn't really explain what this rack macro does, but essentially what it does is it keys that thing up for being able to observe whatever the signal is and set the value of whatever the signal is.
So it's just kind of a wrapper for what you did in the previous slide, where you were creating a signal and then
Yeah.
telling that signal to, I don't remember what the method was, but
Yeah, so basically,
signals.
so I use it in this one as well, but basically what this rack macro is saying is that it's subscribing to this signal, and every time this signal returns something, you set the value of that to whatever's inside the parentheses.
Yeah, okay.
So yeah, those are the basic, oh, slides really got out of order here. Those are kind of those basic two. Reduce doesn't really apply as much here because, or fold doesn't apply as much because we don't know when we're going to be done with the signal. Signals do send it completed, but like with a text signal, it might never ever be over. It just is going to be there for the entire duration of the app. So fold that doesn't really exist on signals. There are some other methods that are kind of similar that you can look into if you need something like that, but they're not very common. I don't think that's really a big use case for signals.
So Jason, would you say signals are kind of like when, forgetting the name, like when you use core data and there's that one controller you can use that whenever data's changed that like it will refresh.
Like a fetch results controller?
Exactly.
Yeah, you can use it for the same type of purposes.
Okay, so it's that same idea, something changes and you can UI, whatever you want to map it to,
Yes.
it changes.
Yeah, so it's got a similar purpose. Well, you can use it in that situation.
Mm-hmm.
In fact, at Instructure, we have our own kind of, we might discuss model view model at the end a little bit if you guys want to see, but we have our own little framework that we built for doing model view model, and we use ReactiveCocoa. We had discussed using core data, but we decided in our case that we weren't going to use core data, so I ended up building out of ReactiveCocoa, so we do basically the same thing. So creating signals. We already showed one way of creating a signal, I think. This rack observe, that creates a signal based off of like some existing property. And that's kind of the KVO part of it. But not all the things that we're going to want to create signals for are KVO. An example might be some sort of networking request, right? I want to go out, do a networking request, come back with the values of my networking request. I want to send them down the pipe so that people can do what they will with them. And then I want to complete my signal. And so this is an example of how you might do that. This is using if networking. Well, depending on how quickly we go through the demo, we'll do our own little one that's using an SURL session. But essentially, we create a signal. And don't worry too much about the internals of that. Just rack subscriber. A subscriber is something that's subscribing to a signal. So basically, in this block, it's passing you the things going to be subscribing to the signal that you're creating, so that you can send it your values and tell it when you're done. So we do our networking call, and inside of our success block, we send the response object down the pipe. So if someone subscribes to this signal, when they get the next value, what they're going to get is the response object, which is, I think it's probably parsing something like JSON or something. If there's an error, we can send an error. So there are a couple methods on signals. There's send next, there is send error, and there's also send completed. And so you can handle all of those things. So say your signal is doing something and you need to error handle. When you subscribe to it, you can subscribe to the errors as well. And so you can handle errors as they come through the pipe. It is important to know though that when you send an error, it completes the signal. So your signal can never send next again once you send an error. Your signal's done for it. And same with sending completed. Hopefully this isn't too out there. We might, if you have some questions about it, we'll get to it in the demo thing. But the last piece is the piece that's a little bit more confusing. And what you're doing is creating a rack disposable, which is a type of signal, but it has to, without getting too much into kind of the memory pieces of ReactiveCocoa, basically it creates a new signal that you can dispose and clean up the memory easily with. And you return this, and what this return value does is this signal we call if you need to clean up the signal. Say in the middle of the signal you decide to cancel it, then you put whatever you need inside this block that you need to do to clean up whatever you're doing in your signal. In this case, we're going to cancel our network request. Okay. If that doesn't make sense right now, that's okay. Combining signals. So this is where we start getting into some pretty cool stuff, I think. First of all, sequencing. So do next is, we'll talk a little bit more about do next and some of its siblings in a minute, but do next is not the same as subscribe next, which is what you typically use to start listening to a signal. Do next is adding, you put that method on when you want to tack on some sort of side effects. And this is sort of an explicit way of saying, hey, we're doing a side effect. An example, in this case, we're logging. Logging is a side effect. But say you want to do something after a signal is done, then you use this then keyword method. So this says, basically what this says is when signal 1 is done, do signal 2. And so, this is something that you might be using, NS operation queues or something for. And you can do this with signals. Merging signals. Basically, it takes two signals, puts them together into one new signal, and whatever values get sent through the signals, then you get both those values. So,
do you give priority to? Just do it in order then? I mean, what if they're doing conflicting things?
What do you mean?
Well, let's say signal 1 is transforming the values, multiplying all the values by 2. Signal 2 is dividing them all by 2. So which one's going to happen first?
So they won't be happening. So if you were, both these signals could be subscribing to the same, say they were both listening to like total, and one's adding up 2 and one's multiplying with 2. Then I'm going to get both values. Because what I'm saying when I subscribe to a merge signal is that I'm saying I want all the values of both of these things.
Oh, so
they're not going to be conflicting, you're going to get both of the values. And if you only wanted one of them, then you should only subscribe to one of those signals in the first place.
Yeah.
So this, it's hard to think of an example on the fly why you might use this. Maybe you have like 2 text fields and you just for some reason want all the values as they come through from those text fields because you're going to do, I don't know. I can't think of a good example right now, but I have used this before. Actually, I'll show you a good example of when you might want to use this later. So it's important to remember that this will complete when both are completed, but it will error when either of them errs. So if one of these breaks, then your whole signal is gone, your whole merge signal. But it will wait until both of them do.
Okay, so I think that's a good example of that, right? Like where 2 events, one cancels out the other event.
Yeah. So basically what this becomes, in a sense, is kind of like a dispatch group.
Yeah.
Because you can merge your signals together, and you can subscribe completed on this, and then you know when they're all done. Right? So, if, for example, if you wanted signal 1 and signal 2 to happen, and then you wanted to do a signal 3 only when those 2 were done, and if they didn't error, then you can go back to this, and you you could do like a then, right? So you could say merge signal 1 and signal 2, then signal 3. Combining latest values. So sometimes you might want to look at multiple signals, but you want to compare these signals together. Example, and we'll use this in our demo. An example might be if you want to compare the values of 2 text fields, right? You update one text field and you need to compare it to the other one. So you need to have the latest value of both of the text fields. So this says whenever either of these signals, either cell1 signal or cell2 signal is updated, then call this block, and this is like some super magical like objectives. I don't even know like what these guys are doing. It's some crazy stuff going on. But first, in some way, like you can create like this block, the parameters into this block, like you can just make them like if you combine 4 signals together, then you just like write down 4 IDs or whatever inside of the parameters for the block, and you get all the values to it. So basically what this is saying is that if we have cell 1 and cell 2, we're subscribing to both of those signals, and anytime that either one of them is updated, I get the values for both and I can add them together. And so this will always have the latest total of both of those values. Does that make sense? Okay.
So you could use something like that for like comparing 2 text fields as they're entering like password and to confirm the password.
Yep. In fact, that's exactly what our demo is going to do.
Okay.
Switching. This one I've never actually used, but it exists. So say that you have, well, let's see if I can remember how this works because I don't use this. So yeah, say you have a signal of signals, and so this is where you're getting like very like, yo dog, I heard you like signals, right? So you have a signal of signals, and you want to switch the signal inside of that signal that's actually sending the values through the pipe. So basically you have like multiple pipes coming in and like one pipe going out, and like you only want like one coming out at the same time, right? In that case, you use this this switching stuff. We're not going to talk about this because you can go to center. Side effects. What is a side effect? Logging is a side effect. Making a network request, updating the UI, changing state. Any of that stuff is side effects. And you should really only do side effects inside of methods that are for doing side effects. Examples are in your subscription. Any of these places are okay to do side effects. So this is there are all kinds of sister methods. You could do like subscribe next completed, or subscribe error completed. Like you don't have to do all of these. This is just all of them together. But so basically we have 3 blocks here. One handles all the values coming through the pipe. One handles if there's an error that comes through, and one handles when the entire thing is done. So these are all appropriate places to do side effects. But this is happening at the subscription level. This is happening at the level where you're saying, hey, I'm going to accept all the values coming through the signal. What happens if like a signal wants to inject these? Like maybe it has like its own side effects that it wants to do. And this is where you're getting into kind of dangerous territory. Like whenever you're thinking like about like, oh, what if I inject side effects? You need to start thinking, is this really something that I want to do, and is this the appropriate place to do it? But if you want to do that, then you have these methods. And these don't actually subscribe to the signal, so you're not actually starting the signal up. Signal still. They talk about hot signals and cold signals. Hot signals are essentially signals that are already running. They've already been subscribed to. And cold signals are ones that aren't doing any work yet. And so these will keep the signal not subscribed to. They'll be cold. But so say that I have a signal, and then I put like a do next block on it and do some stuff. Then I can give that signal to someone else, and then when they subscribe to it, then these side effects will start happening. Does that make sense?
Yeah.
Okay. And if you want to inject something before the signal happens, like there are like a lot of cool methods. Like every time I'm like, man, I wonder if ReactiveCocoa can do this thing. Somehow it does it. So this one will inject it before the signal starts up. So say like you have a signal and you're like, wait, before this happens, this side effect needs to be set up. And so you give the signal to someone, as soon as they subscribe, that happens, and then it launches the signal. So, pretty cool. Some more side effects. This is an example of what I'm talking about that you shouldn't do. So, showing alert is a side effect. Mapping is something that's just transforming data. So you shouldn't be inserting side effects. Like, this will work, and it will do exactly what you expect it to, but it's not a good practice. What you do want to do is something like this. So you do the map, and then you can do this other little side effect. And so whenever you say do next, that's basically a little documentation saying, hey, I'm doing side effects right here. Yeah. So we already talked about creating the signal with the create signal method. There's also this thing called ReactSubject. And it's an object that basically is the subclass of ReactSignal, and you can send values to it and send completed through it and do all those kind of things. But it's an object that you can like have as a property. And so these are really cool because you can use these to like basically create your own signals, be very flexible. But you should be using create signal when possible, because of the nature of the game, you know, you're trying to like keep your code clean, you're trying to follow good practices. Using ReactSubject tends to lead to things that are less functional reactive programming. But it is there in like cases where you're using your good judgment and you think that you need it. It's also the basis for a lot of these things. It's also the basis for replaying, which we might talk about in just a second. Concurrency, so this is something we already talked about, and I duplicated this slide. So this is like, you know, I want to do 3 networking calls, and then when they're all done, I want to do something else. So what you think to myself is I want to merge all these signals together, and then I want to do something else. So this is the code for basically creating a dispatch group for all those, and then when those are all completed, assuming they don't error, then I run this other thing. Yeah.
Okay, and the thing would be, so if you did 3 networking calls, one of them, an error was shot off in one, you'd get that in this kind of combined thing.
So this doesn't actually subscribe to the signal, so I won't get an error at all until somebody subscribes to this.
Oh, okay.
And when someone subscribes to this, then they can also subscribe and listen for errors, and then they can handle the error. But this doesn't actually do anything. It just creates the signal that someone can subscribe to.
Gotcha.
If that makes sense. Okay, replaying. So replaying and multicasting, which is my next slide. They're just words I put in some slides. They are some of the areas of ReactiveCocoa that I understand a little bit less, but that said, I do understand some of it. So an example of replaying is, say you have a networking signal that's doing some sort of side effect, right? There's sometimes when you want to create a signal, but you don't want to have to do the networking request every time, right? So in an example like, so if I'm subscribing to this networking signal, every time I call subscribe on that signal, it's going to redo that networking call. And maybe I only want to do it once, and I just want to keep the value, and I want to replay that value every time to new subscribers. So that's what replay does. Replay, you can just tack that on at the end of your little chain of ReactiveCocoa methods, and it will basically keep that value, it will cache it for you, and it will just replay it every time someone subscribes. Does that make sense? Okay. Multicasting is similar. In fact, I think this is where it's a little bit ambiguous, but I'm pretty sure that what replaying does is it creates a multicast ReactSubject, and multicasting basically does that replaying. Yeah. So we talked a little bit about network requests and sharing side effects. If you want to share the side effects of network requests, you should use replay. And so this is really just like brushing kind of the tip of the iceberg of what ReactiveCocoa can do. Another thing it can do is it can replace delegation. You can actually, and maybe when we do the demo I'll show this, I don't have like there's a couple times when I've used it, but I don't have a good example of why we should use it in the demo. But you can, set yourself up, for example, as like a delegate for UI text field or something, right? And you can call a ReactiveCocoa method that will, for a certain protocol, subscribe to a certain method. So every time that method is sent to the delegate, your signal will get triggered. So you basically just turn that into a signal. I don't know that it's like the best thing ever to do, but I kind of like it because it's cool. But yeah, you can do that. There's a lot of stuff that you can start doing.
By that, do you mean some of the individual methods that would get triggered? Like, for example, text field should begin editing. Like, you subscribe each one to the
So, yeah, an example of where I've done that, or I've actually used this, is with text fields and specifically when it's done editing. And I have like a couple different things I want to do when it's done editing. And I just subscribe in multiple different methods to that signal, and then I handle that. And so once that delegate method's sent, then I handle it in a bunch of different places. I haven't decided whether that's, on one hand it's really cool to be able to like wherever like have that code. So for example, you have that code where you want to handle that situation next to other similar code. But on the other hand, I don't know if it is, I can see pros and cons. Like I can see some pros to having an actual delegate method and you have all the code just in one place. So I don't have tons of experience with doing that. I don't know what the best practices there are, but it exists and it's kind of cool. Other super cool methods, throttle. Say you have a signal and you only want it, you're like, this is happening a lot of times. I only want it to happen like once a second or something. You can do that, you can throttle it. Take, well, we'll skip take. Take is a little bit more like functional stuff. And well, okay, we'll talk about take. So say you have a sequence, you can call take, and you can take only like the first 10 values from the sequence. So essentially that will evaluate the first 10 values from the sequence, and you'll have those as a new sequence. Take until is something that you would use on signals, and the until part, the parameter that you're passing into that, is another signal. And so basically you're saying, do this signal, but you're terminating as soon as I get any value from this other signal. And this isn't something that I've used a lot, but one place I have used it is if you start using these bindings inside of table view cells. Because of table cell reuse, like you can't bind again to the same label or whatever, or to the same stuff. And so table cell reuse will really start messing things up. But if you tack on take until, there's a signal that's a reuse signal that gets fired. And so basically it will take your values and your binding until it gets a reuse signal, and then we'll stop taking it, and so we'll end that subscription, dispose of it. Set name with format. I was trying to do this earlier. I don't use this a lot. I feel like I should because it's really cool. Essentially what you do is you're setting a name for your signal. You can name your signals because one thing, and this is one of the pitfalls of ReactiveCocoa, is that debugging is different. I can't say that it's hard because debugging is just hard in general, but it's different. And I'm not used to it. I don't think a lot of people are. So it's much different to approach debugging signals. But you can set name with format on it, and so you can name it, and you can, it's a format string, so you can like insert the values like the current whatever values that it has. And actually it's pretty smart about like the default name that it gives it. It will tell you like what the values that are, like for example if you're doing like a map or something, it will like tell you what the values coming into the map are and what it's putting out of the map. So it's also got log next, log error, and log completed, log all. So if you just tap log, like if you want to start debugging, you don't need to start putting NS logs inside of your ReactiveCocoa log. So you can just tap log all on the end, and then you'll start getting all the stuff just logged out for you. So it's pretty slick. Right now you might be like, my head's exploding. This has been a lot of stuff. I know it's been a lot of stuff. I'll give you guys the slides. But 99% of the time I find that these are the methods that I'm using. I feel like when you're using these things, I guess I put switch to latest on here. After I said it's that method I never use. I really don't use it very often. But these other ones, use all the time. They're your friends. We didn't really talk about flatten map, did we? We'll talk about flatten map. So So flatten map, all it does is it flattens your signals. In this case, it it's merging. Well, let's go. Maybe we should find that slide before I just start ad-libbing.
We didn't talk about one flatten method. I don't know.
Yeah,
Different from flatten map.
Yes. So flattening just flattens it. Flatten map flattens and maps it. So it does both those things together. So an example here, this is kind of, so you have an array of letters. And basically what you're doing here is you're looping through the letters. And for each of the letters, you're going to go out and you're going to save all of the entries. I don't know what kind of application this would be. You're going to say like some sort of address book or something. You're going to save all the entries for a certain letter into the database. But this thing that you're returning is also a signal. So you're returning a signal inside of your map. So you're saying for each of these values, I'm mapping it to a new signal. And so these signals all go out, they all save to the database, and then they complete. And so once all of those are completed and they've all been done, so that's the mapping part, right? You've mapped all the values inside of letters, and the value that you mapped them to was a signal. You do that signal. So all of the mapped signals get merged or get flattened into one signal. And so when all of that work's done, then you subscribe completed. I'm trying to think of an example of where I use. So one place I remember using this off the top of my head is so our networking library at work, we've done entirely in ReactiveCocoa, and so one place that I use this for sure is when I'm doing the OAuth. And in our actual OAuth process, we end up sending off a bunch of signals, and we have multiple signals that we're needing to handle. But at one point, you want to do oh gosh, I'm screwing this up. Anyway, this is. Do people understand what at least this piece is doing? Yeah. Okay. All right. So. Yeah, this is your hammer. These are the methods that you're going to use the most. If you want more, ReactiveCocoa documentation is really, really, really good. There's design guidelines. It's very good. There's one, basic operators, which talks about all the operators that we talked about tonight. There's just really good documentation. I can't stress how good it is. That's the place to go to. And the header files are really good as well. They're really well done. This book by Ash Burrow is really good. If you're into books, I would suggest this one. There aren't really any ReactiveCocoa books besides this one, but it's a good one. If you're interested in...
How recent is that book?
Hmm?
How recent is that book? Does it cover
It's
the latest
really
stuff?
recent. I think he just updated it a couple weeks ago with a new chapter on model view model. Yeah. That said, I don't think that at least the last time I read it, I remember going and finding some better ways to do things after, but he does a pretty good job with everything in general. You go through and build basically a Flickr little viewer application for viewing photos from Flickr, and you do it all with ReactiveCocoa. So, GitHub has also pushed this out, Reactive View Model. If you're interested in MVVM, this is a good place to start. If you're interested in more of the networking stuff, OctoKit, which is GitHub's own API wrapper networking library, is all done with ReactiveCocoa. And at Instructure, we went and modeled ours after that. So you can also look at our library as well. So pitfalls, don't cross the streams. Type safety. So I don't know if you noticed, but with all our blocks, the parameters that come into our blocks are always ID. And because of the way, maybe if we had a crazy type system like Haskell or something, we wouldn't have this problem. But as it is, we lose our type safety with ReactiveCocoa. That's just Personally, I never leave anything as ID up inside the actual parameters to the block. I like to be explicit about what's coming in, so I put the correct type and I put it like a descriptive variable name, but that doesn't stop you from getting the wrong values. Like if you say it's an NS string, okay, you say it's an NS string, but maybe you really just got an NS number past it. So you just need to be careful about that. I thought about putting asserts inside of all those blocks. I haven't done it though because I haven't looked into it too much, but like as I was having that thought, there's a big explosion on Twitter as everyone like remembered that like NS assert like has self in it, and so it might cause retain cycles, I don't know. So that might still be good practice, I don't.
You can also use NSC assert.
NSC assert?
It's a C-based implementation, so it doesn't
Right.
have self in it.
Yeah, that's a good idea. NSC assert, there you go. Robert has a lot. View did load bloat. So as you start doing ReactiveCocoa, typically the place where you set up your bindings is in view did load and view did load. So your view did load will start to get pretty big the more and more reactive bindings you put in. So what I like to do is I like to break my stuff up into setup methods. So I'd be like set up a text field, and all of the bindings related to that text field are in that method. And so that's how I deal with that. But yeah, any questions on the slides?